Welcome to Control Flow lecture. So control flow consists of three statements, which are if, else, and elif. And what they do is add logic to our code. The if statement performs a task if the condition is true. The else statement performs a default task when the if statement's condition is false. Else statements cannot exist on their own. The elif statement, short for else if, works in between if and else statements. An elif only performs a task when true and the if statement is false. And this all depends upon what's called indentation, which is something very unique to Python. And I'll elaborate upon that in a moment. But for now, just going to scroll down. And we have here a total of 4 variables, A, B, C, and D, 3 of which, as you can see, are integers. And the last one is a tuple that contains a list contains strings, in this case, cat, dog, and bird. So they're within a tuple. And we're going to do our first control flow. So if A is equal to 10 and B is less than 40, colon, and if I hit enter, notice it will go onto the second line with an indentation here. So there's a space here. It won't go here. If I hit the tab, we'll go back to there where it originally was at the beginning. And then we do print this is true, and we have the output of this is true, and that's because the if statement evaluates the true because A is equal to 10 and B is less than 40 is 25. And let's say, for instance, I were to move this here. What do you think is going to happen if I run this code? Well, if I run it, we get what's called an indentation error expected in an indented block, and the indented block is what this is here. So every time you see a colon here and you hit enter on the next line, it's automatically going to put the cursor in this indentation as opposed to being here at the beginning. So that's how Python works. That's a way of making it very elegant compared to other programming languages. Okay, so let's say, for instance, this was false instead of true. So the if statement evaluated to false. So let's say, for instance, we had 100 here. And we run this, we don't get any output because this is false, and therefore we don't have the print statements. And let's say, for instance, we could, instead of having an and, we could do an or. So the A obviously is not equal to 100, but B is less than 40. So what do you think is going to happen? Well, if we run this, we get true, because at least one of them has to be true for this print statement to be output. Okay. And what we can also do, just go back to having it as an and, let's put this as 10. We can do 2 if statements. So we do if A is equal to 10, colon, and then you have the indentation here automatically when you hit the enter. Then what we have here is a nested if statement. So B is less than 40, colon, print this is true, output. And there you go, you have the exact same output. So we have a nested if statement, and in both cases it produces the same output. Because we're using the same exact logic, it's just arranged in a slightly different manner. Okay, so let's just delete that. And what we're going to do now is something a little bit more interesting. So say, for instance, we can do an else. We'll do print this is false. We still have this is true as the output because the if statement evaluates to false. The if statement evaluates to true, excuse me. But say if I were to change this to 100, now it says this is false because the if statement evaluates to false, so the default argument is printed out. Okay, so moving on from that, what we can do is something a little bit more interesting. I'm just going to comment that out to get rid of the error there. Then uncomment it. And we have if A is equal to 10, print A is true. And then we'll do a nested if. So we'll do B less than 40, print B is true, else, I'll make a space here actually, else print B is false. And then we'll do an if for A, or rather an else, sorry. Else print A is false, exclamation mark. So we run this, we should get two trues, so A is true and B is true, and we do. So what's happening here is that because A evaluates to true and B evaluates to true, you have both of these print statements. But let's say, for instance, we put this to 4, because we know B is 25, and 25 is obviously not less than 4, so if we run this, we get B is false. And if we were to change this for the first line and put this to 100, well, we know that this is going to be false, and this line here is false, so we're going to have, what do you think? Do you think we're going to have two false statements, or only one? Well, we only get one. And that might be a bit of a surprise to some people here, but what's happening is that Python is reading from top to bottom, so from the first line to the 10th line, and if it finds that there is a false statement, then it will default to the else statement and print that out, and it will completely ignore the nested if statements and the else statements. So in order for B to be checked, A has to be true, otherwise you only have the else statements. Okay, and we could reinforce this point by doing another nested if. Let's say we do C. C is less than, let's say it's greater than 10. Let's do 9, colon, print C is true, else print C is false. If we run this, of course we still have A is false because it's ignoring all the other code. So we put this to true, and what's going to happen, do you think, is that what's going to happen is we're only going to have the output of B is false along with A is true. Okay, so what's happening is that, like before with A, since B is false, it's going to ignore C, and therefore you're only going to have the output of B is false. But if we were to make this true, so instead B is less than 40, which is true, then you have A is true, B is true, and then it will evaluate C, and C will also be true. So we have three true outputs, A, B, and C. If we were to put this to 900, because we know C is equal to 100, then this is going to be false. So we have C is false. Okay. And we could do one more just to reinforce the point again. Another nested if. So D, let's say if, let's do cat in D, colon, print D is true, else print D is false. And if we run this, we don't have the output of D because C is false, but if we make C true, then we also have D is true. And let's say we change this to, well, we've got bird, so we'll also have true as well. But if we change it to, say, I don't know, zebra, then we have D is false. Okay, so moving on from that, what we're going to do is we're going to do a input. So if I do num equals input, enter a number, and this is a Python built-in method called input. So if I do type input, it'll tell you it's a method, and let's just put a colon there as well. Okay, and then if I do num, let's say I put 90 in, you notice that we have what's a string. It's not actually an integer, but it's a string of an integer. And if I were to do type num, as you can see, it's a string. And if we want to convert this into an actual integer or a float, then we do eval, Okay, and if I run this again, I put, let's say 100, we get 100, the integer. If I just check that with type, we get ints. And we could also do the same thing here for floats. So 9.123, and we check again, and we have a float. Okay, so we're going to be using this for another control flow. So let's just delete that, and we do if num is greater than or equal to 3, colon, print, keep looking. What we're going to be referring to is D, which is the tuple. So this would be the 0 index, first index, and second index. So if it's equal or greater than 3, then obviously we're not going to be able to find any of the elements, which are these strings, in this tuple. So that's why we say keep looking. And then if we do elif, let's make a bit of space here actually, elif D num, so we're selecting the index here, equal to cat, colon, print, found a curly brackets dot format, if you remember, D num. Then we'll do another elif D num equal to dog, colon, print, found a dot format. This is exactly the same code as above. Okay, so we don't actually need the else statement in here for the code to operate, but I'll show you what it looks like without the else before we go and put the else into this code. So if we put 0, we get found a cat, we do 1, we get dog. But what happens if I put in, let's say, 2? There's nothing because we haven't selected bird. Now we could do the same thing again, another elif statement like this for bird, but that would be quite wasteful because it's a lot more code to write and it's very repetitious. And we want to keep our code dry, which stands for don't repeat yourself. Okay, so say if I were to put in 4, it says keep looking. So if it's equal or greater than, so if it's greater than or equal to 3, then I'll say keep looking. But with 2, it doesn't work. So we do 2, we don't get anything at all. So that's when the else statement comes in. So we do print found a bird. Let's do 2, and now we have found a bird. Because this is going to be 0 for the cats, 1 for the dog, and if we go 3 or above, it's going to be keep looking. So logically, we're only left with the number 2. That's why we can just do else instead of writing this elif here. Okay, and we can have as many elifs as we like in between the if and the else. So moving on from that, what I'm going to do now, just scroll down here, is create a nested list of numbers. We'll do it as total, so the variable called total, and we'll put it in square brackets. We'll do list range 11. We'll do list range 10 to 21, and then lastly list range 20 to 31. And then we'll do total. And as you can see here, we have 3 nested lists of 10 integers within each of them. So 0 to 10, 10 to 20, and 20 to 30. Okay. And what I should probably do is change that to there's a slight problem there. The slight problem I'll mention in a moment, but we'll just leave it as that for now. Okay. So what we'll do is some control flow with this total list. And just to show you, of course, if we were to do indexing of, say, 0, we get the 0 to 10. If we were to do, let's say, 1, we get 10 to 20. And, of course, if we do 2, we get 20 to 30. And ideally, what we should have is none of the elements shared between any of these nested lists. That's the issue here. So what I could do is just 11. And I could do 11 here, or 21 rather. There we go. Okay, that's better. Alright, so what we're going to do is v equals eval. If you remember, we have to use the eval to convert the inputs into an integer instead, or floats, instead of being just a string. And then we'll do enter a number. We'll do if v in total. So we'll select in the first nested list, print v in list 1, elif v in total. This is quite similar to the d tuple that we were using before. Print v in list 2, and then we'll do elif v in total 2, print v in list 3. Okay, and we run this, well, like before, we're not going to do the else statement just yet. So let's say we do 0, we do 4. Then you have 4 in list 1, which it is. As you can see here, 4 is in list 1, or the first nested list. If we're to do, let's say, 20, 20 of course is in list 2. And if we're to do 28, it's in list 3. But what if we were to do some higher number like 40? What we do get in the output? And that's where the elif, or rather the else statement comes in. Excuse me. We'll just make some space here actually. Else print not in any list. And now if we do 40, we get not in any list. Okay, great. So that concludes my lecture. I hope that's been insightful. If you have any questions, feel free to ask. Thanks.